Hello, Ryan. Good morning. Welcome back. Another minute, folks, and we'll get ready to roll. If anybody in class needs a hard copy of the note packets over there, help yourself. Self-day materials indeed. Anybody in class need anything? Good? All right. All right, good morning. Welcome back. I hope you guys are all doing well, staying safe, and especially I hope you had a great weekend. Nice Mother's Day weekend. If you have mom in your life, lucky enough to have mom in your life, hopefully you gave her some love and appreciation for yesterday. I'm looking for a couple people today. I'm looking for Micaiah. I'm looking for, Joe's here, right? Never mind, Joseph. Just Micaiah, Tintin, and Nidell. If you're here, please let me know. Again, unmute or please put your name in the chat. Nidell, Tintin, or Micaiah. Oh, sorry, Tintin. I knew I missed somebody today. Thanks. All right, let's get at it. Here we go. The COVID numbers for the weekend. Let's see what they are. So right now in the county, great number. I want to broadcast this number. Right now in the county, in Oneida County dashboard, this data presented by Oneida County, there's 308 active cases in the county. Remember like a couple weeks ago, there was over 400. Now we're almost below 300. Hopefully we keep decreasing the numbers of cases. Good sign right there. Resolved cases, 21,045 resolved cases. Number of deaths from COVID, 421. So one more person passed away from COVID over the weekend. People in the hospital. There's 10 people in the hospital and 7 people in ICU. Not the best information there. 7 people in ICU. 10 people in the hospital. There's 7 people that are in intensive care units. That's a little scary. So maybe, hopefully not, but maybe there's going to be a couple more deaths from people struggling in the ICU. Vaccine numbers are increasing. You can see that. We're almost at 50% of the total population of Oneida County above 16 that are 50%, 47%. They're slowly increasing. Hopefully they increase at a quicker rate. Again, if you're above 16, you want to get vaccinated, you have the ability to. Check out the Oneida County website. There's definitely different pods, different locations going up all over the county where you can get vaccinated. I do not have any more information from Pfizer on the age 12 through 15 yet. Hopefully that'll be rolled out soon. All right, there's a trend for COVID per day. You can check it out. It's really tough to predict what's going on here now. It's very similar to May to October, this data. But it's at a higher level. We really can't figure out this trend. We don't know what's going on with the COVID. Increase, decrease, day by day, you really cannot predict this trend. It's all over the board. We had an idea of what happened around November and December. We predicted that it's going to increase, increase, increase. We predicted the decrease. Once we saw that trend, we started to predict that decrease. But now we're really all over the board. Let's see what those numbers are. Number of COVID cases per day in the county. Last couple of days, the 8th, there was 29. The day before that, there was 53. Number, we didn't want to get above 50 again, but we were. The 6th, there was 23. The day before that, there was 42. The day before that, 23. And then the week before that, we saw this, and I was really happy. I'm like, wow, that's a great decrease. But again, we have this next week, which is a mystery. We'll see. A reminder, COVID's definitely in the area. Be smart, be safe, protect yourself, protect your loved ones. Do what they say. Wear a mask, social distance, all that stuff that we've been talking about since the beginning of the year. Okay. Good morning. Please try to get here a few minutes earlier.
I'm sorry, I had to restart my computer like 3 times. It wasn't
It
working.
happens. All right, thank you. All right, let's figure out what's going on for the best class today. Here we go. Organic chemistry today. Let's figure this out. Welcome back. Quote of the week comes from Albert Einstein. His quote is, if you can't explain it simply, you don't understand it well enough. If you can't explain something, maybe it's something in math. If you can't explain how to do something in math class to your friend, a question in math class to your friend, maybe you don't understand it enough. Maybe it's in this class. If you don't or you can't explain something simply, then maybe you don't understand it. Hopefully, we go through these. I'm teaching it to a simple way, and hopefully you can understand it and teach somebody else in a simple way too. Albert Einstein with that quote. Today's Monday, May 10th, 2021. It's a day one. We're going through Unit 10, Organic Chemistry today. We're going to talk about Topic 1. We will finish out Topic 1 today on organic basics and hydrocarbons. We'll go through some guided notes. We'll watch a couple of YouTube flicks, one on formulas, one on hydrocarbons. And then we'll go through some examples on an easy topic if you pay attention today. And you should have time to complete the exit pass at the end of the class. You do need a reference table for today. If you want to watch these videos over and over again, you have the ability to do so. Let's go. Here we go. Please open up your guided notes. We are in organic chemistry. Organic chemistry. Looks like this. All right, what happened last time? We started talking about basics for organic concepts. We didn't get to hydrocarbons yet. We said organic chemistry is going to be the studying of carbon atoms and the interaction of carbon atoms, of how they covalently bond two or more nonmetals. We said organic chemistry dealing with carbons. There's more organic compounds than inorganic. We also said organic chemistry deals with chains, rings, or networks. And then we just said organic compounds, they bond with 4 other atoms. Carbon atoms has 4 valence electrons. It could potentially bond with 4 other things. Let's take a look at something real quick. Let's look at a ball and stick model kit for a second. I know they look like gumballs, but they're not. So this ball and stick model kit here, each atom represents a different color. So there's different atoms within this model. Black ball, the black sphere is going to represent carbon. If you look at carbon real quick, carbon, how many empty holes are there? There's 1 there, 2, 3, and 4. There's 4 empty holes in that sphere. That means it can form 1, 2, 3, 4 more bonds. So this could bond with 4 other things. 4 more bonds it could have. These little ones represent hydrogens. There's only 1 more dot there, 1 more empty hole there. That means it could bond with 1 more thing. The red's going to be oxygen. Nitrogen's going to be blue. Nitrogen would be blue. Gray is going to be boron. Yellow sulfur. Green is going to be chlorine. Bromine's orange. And fluorine or iodine is going to be purple. But whatever. We're really going to focus on the black spheres and the white ones today. So if carbon has 4 valence electrons, it could potentially bond with 4 more things. 4, 5, 6, 7, and 8. Those 4 sticks would represent sharing of 4 more electrons. What could bond with it? It could bond with an H. These are H's. This would be CH4 or methane. And they're all single bonds in between that as well. So this is going to be a stable octet. Carbon had 4 valence electrons. these sticks, how do they work out? I think of these sticks as one electron on one end of the stick and another one on the other end of the stick. So this is going to represent 2 electrons a stick. There's going to be 2 electrons here, here, here. 2, 4, 6, 8 electrons on this carbon atom. That base stable octet. But we'll talk about more examples as we move on forward. That is an organic compound for methane. Methane, how would it look? Draw some stuff here. Methane, this atom, we have a carbon. That's going to have 1 dot there, 1 there, 1 there, 1 there. There's not too much of glare there. And then off of that, there's going to be an H with another dot, an H with another dot, an H with another dot, and then an H over here with another dot too. That could be represented. See some lines there. There's another way you can represent this model above. You can represent this with the molecular formula, which we'll see today. It's how many carbons are there? There's 1 carbon. And how many H's? There's going to be H, 1, 2, 3, 4. CH4. This all relates to methane, which we'll go through today's class. All right, let's check out some information here. All right, so we talked about carbon. We know carbon atoms. 4 valence electrons, chains, rings, or networks. And organic compounds. Organic compounds containing only single bonds. There you go. Only single bonds, like the example I talked about, are said to be saturated. Single bonds are going to be saturated. So if it's 1 stick between 2 atoms, it's going to be said to be saturated. For example, the diagram over to the right, the picture to the right, it's saturated. There's all single bonds in between. So what's going to happen? I'm going to start to introduce naming these organic compounds. Some of you guys are going to understand them with a couple examples. Some of you guys are going to need a few more examples to really interpret these or understand them. It's going to take some practice. The more I introduce it, the more I talk about it, the better off we're going to be. So here we go. We're definitely going to need a reference table. I know. Need a reference table to figure out what this name is going to be. First thing you want to do with naming organic compounds is to figure out how many carbon atoms are attached to each other. All right, so that diagram to the right, that structural formula to the right, we have carbon 1, we have carbon number 2, it's connected, carbon number 3, it's connected, and there's a 4th carbon connected to each other. There are 4 carbons connected to each other. Now I'm going to look at the reference table. Let's check out the reference table for a second. I don't know why it keeps doing this to me. So pull up in the reference table, look for 4 carbon atoms, and on page number 7. On page 7, there's going to be a little key to tell you the name of these organic compounds. On page 7, right in the middle, it says table P, organic prefixes, if there are number of carbon atoms. If there's 4 carbon atoms, 4 is going to be represented by the prefix but or but. So the name is going to be but or but. So 4 would represent these 4 carbon atoms. And then if it's a single bond, double bond, or a triple bond, to be indicated by the chart below. So let's check out that chart below for a second. And how does this chart work out? It says homologous series for hydrocarbons. We have alkanes, alkenes, and alkynes. Alkanes, alkenes, alkynes. Anes, enes, ines. A, E, Y. Difference of 1 letter that's separating the alkanes, alkenes, alkynes. Alkanes represent a single bond. Alkanes represent a single bond between carbons. Anes, single bond. Alkenes represent a double bond, and alkynes represent a triple bond. So just like the alphabetical order, A, E, Y, single, double, triple, single, double, triple. The molecule we're looking at is all single bonds. If you look at the molecule in the notes, the single bonds, you can look at the example. The ending is going to be ANE, ANE, single bonds, anes. If there were a double bond there, it'd be ene. If there were a triple bond, it would be ine. And they give you an example to help you out with the situation. All these examples here, if we analyze this quick, we can check out the examples. They say F, F, F. What does F refer to? It refers to two carbons. Carbon 1, carbon 2. Carbon 1, carbon 2. Carbon 1, carbon 2. So all three of these examples have two carbons bonding. One's a single bond, anes. One's a double bond, enes. And the last one's going to be a triple bond, ines. All three are going to be homologous series. F refers to two. So the name of the compound in the notes for the example, which I don't expect you guys to know how to do this yet, would be 4 carbons, but they're single bonds, ane. Alkane series. So butane would be the name. If you double click on the image, it'll bring it to the diagram. We'll just identify the name right there. Butane. Butane. That tells you 4 carbons. ANE tells you it's going to be single bonds in between. Do I expect you to know how to do that yet? No, I don't. But I will be going through that several times. Butane. 4 carbon atoms attached in single bonds. But tells you 4. Ane tells you single bonds. So please save that image. Didn't think it'd work out here. Let me reload my page. Hopefully we'll get there. Butane. First one, done. So notice that that's all single bonds in the first example. Let me make a model of butane quick. So after I save this, I'm going to make a model of butane. Come on. So close. Come on. Third time's the charm. Hopefully. All right, so again, this is going to be butane. Hopefully yours saved. And you have to cut it and paste it 3 times like myself. Save. All right, cool. So butane, let's make a model, a ball and stick model of this butane. So butane. Butane, what do we know about butane? There's have 3 carbon atoms. How many? 4. 1, 2, 3, 4. Definitely need 4 carbon atoms. And then we also need some sticks to represent single bonds. So the first carbon atom, what I'm going to do, I'm just going to connect or fill all the holes of the first carbon. And then I'm going to connect it to another carbon, carbon number 2. Fill all the holes of the second carbon. These would be H's attached to that. This would be carbon number 2. That would be ethane with H's attached. Next up, connect another carbon atom. This would be carbon number 3. Fill the slots that's valence electrons. Notice that each hole is going to be filled with valence electrons. Will be a stable octet. And last one, 4 carbons. There it is, carbon number 4. Fill the holes. There would have been a lab on organic molecules with balls and sticks, but this year, you know, crazy year. Last thing, attach some H's to that. H's, the smaller spheres. They have 1 valence electron to give off. Each one of the sticks is going to have 1 valence electron to give off. When all said and done, this will be a stable octet. Getting closer, folks. Two more. Again, this is going to be butane. We'll see the difference between butane and butene, which is the next example. All right, again, all the holes are filled. I rotate this thing around, you'll notice that there's no empty slots. Butane. Stable octets. Each carbon's going to be stable. That's what it looks like. Looks similar to what we have in the notes. Check out the example for butane. You can see it. You rotate it around a little bit. The ball and stick model versus the structural formula. So structural formula, ball and stick model. This would indicate carbon number 1. Carbon number 1. Around that first carbon is going to be 3 white spheres, 3 white balls. 1, 2, 3. True. 1, 2, 3. Okay. Second carbon has, hopefully you can see it, 2 white balls. 1, 2. Second carbon has 2 H's. Third carbon has 2 H's. 1, 2. Third carbon has 2 H's. And the last one has 3 H's around it. 1, 2, 3. You can see in the notes, 1, 2, 3. That is butane. But tells you 4 carbons. Ane tells you single bonds between the carbons. Let's try the next one. Double click on this one. Let's edit this one again. This one's going to have how many continuous chain of carbons? 1, 2, 3, 4. So it's going to be but again, or but. But we have a double bond this time. So this is going to be not ane, but rather it's going to be ene. Butene. ENE is going to be the ending. The ENE is going to tell you it's going to be a double bond somewhere within that molecule. This is going to be butene. One other thing, there's going to be a number to tell you what's going on or where the double bond is. You start to number the organic molecule to the side closest to the double bond or the triple bond. So in this situation, the double bond's closer to the right. This would be carbon number 1. This would be carbon number 2, 3, and carbon number 4. So the number that's going to be placed out in front is going to be where the double bond is going to be. This would be 1 butene. What does that mean again? It means at carbon number 1, you have a double bond, an ene. What's an ene? It's a double bond right there. So this would be 1 butene. Do I again expect you to know how to do that yet? No. You will. Some of you guys understand that right with one example. Some of you guys need about 10, which is fine. There's a whole topic devoted to naming organic compounds. This molecule that we have in the notes would be 1 butene. Let's make that one. Let's make 1 butene with a ball and stick model. As soon as I get this thing to save again. Still don't know why it does this to me. Cut, paste. All right. 1 butene. But tells us 4. 1, 2, 3, 4. I need a double bond in here. So what's going to happen? The sticks represent single bonds. The springs represent double bonds. Taking 2 springs out here. I'm going to break this bond. Boom. I'm going to throw a spring in there. Replace it with a carbon. All right, now it's not a double bond. It's more like a single bond because every hole is filled. I need another spring in there. So I'm going to take another H off. I'm going to connect it with another spring. And it's got to be connected to another H on carbon number 1. This would be 1-butene. Carbon number 1, carbon 2, 3, 4. But tells us 4 carbons. Ene tells you there's a double bond. Where is it? At carbon number 1. All the holes are filled. This would be a stable octet too. That is 1-butene. 1-butene. This example is going to have a double bond, so more in the notes. Organic compounds containing one or more double or triple bond. Double or triple bond. One or more double or triple covalent bond are said to be unsaturated. So the example to the left has a double bond, that's going to be unsaturated. The example to the right has a triple bond, that's going to be unsaturated too. I think you guys probably could name this by now. Maybe you could. There's how many carbons? 1, 2, 3, 4. So it's got to be buts. So 4 carbons represents but or but. There is a triple bond. You see that triple bond? The ending is going to have to be ine, Y-N-E. Where is that triple bond? It's going to be at carbon number 1. So again, numbering it. Carbon 1, carbon 2, 3, and carbon number 4. Where is the triple bond? It's at carbon 1. So again, this is going to be 1-butene. The number 1 indicates what's going on. Where is the triple bond? Where's the double bond? I'm going to highlight this in a different color just so you could understand the endings. 1-butene. But tells us 4 carbons. But tells us 4 carbons. Ine tells you there's a triple bond there. 1-butene. Let me go through and actually make this model as well. Yeah, why? So we'll make 1-butene. Hopefully you labeled it. Hopefully it's saved. Again, we'll practice more and more of these names and identifying how to identify these names, these cool organic compounds. Nice. 1-butene. 1-butene. Here we go. Butene. Butene is going to have 4 carbons. 1, 2, 3, 4. All right. But it's going to have a triple bond instead of a double bond. So I'm going to take away these 2 H's. I'm going to add another spring in between. That'll be a pretty quick demo on butene. Springs in. That is a triple bond. This would be 1-butene. It's 1-butene if I have it this way. If I rotate 180 degrees, it's still going to be 1-butene. So I don't care how I rotate this thing around. It's still going to be 1-butene. Think about it. The longest continuous chain of carbon atoms is 4. 1, 2, 3, 4. 4 carbon atoms represent the prefix for but. So but, there's single bonds here, but there's a double bond or triple bond. That triple bond tells us the ending, ine, alkyne. And then that ine, so it's butene. That ine, triple bond, is going to be at carbon number 1 to carbon number 2. So it's 1-butene. Maybe you understand that. If not, we'll practice more of those examples. All right, moving on forward. Now let's analyze 4 different types of formulas for organic chemistry. The first one's going to be molecular formula. A molecular formula, it's a very basic formula. A molecular formula is not going to give you that much information. It's going to tell you which type of atoms, what kind of atoms are bonding. So again, molecular formula is going to tell you the type of atoms in a compound, type of atoms or kind of atoms, type of atoms in a compound, types of atoms in a compound. But it also tells you the number of atoms in a compound too. We're not getting any information about bond shapes or structural formula. All we're getting is information on what kind of atoms are bonding and how many, the number of atoms in a compound. Very basic formula. Molecular formula just tells you how many atoms are bonding and what kind of atoms are bonding in the compound. For example, below we have C3H8. That is a molecular formula. That molecular formula, you can figure out that there's going to be 3 carbons. This compound has 3 carbon atoms. And it also has 8 hydrogens. Again, tells you how many of each atom are present. 3 carbons, 8 H's, 8 hydrogens. The example to the right, C8H18, tells you the kind of atoms and how many. You'll definitely see the difference as we proceed through class. C8H18 has 8 carbons, 8 carbon atoms, and 18 hydrogen atoms. It's not giving us a lot of information. Yes? This? 3 carbon, 8 hydrogen. 3 carbon, 8 hydrogen. Molecular formula. Yeah, we definitely could take the example we did earlier and said, what's the molecular formula for that? And you say, oh, there's C4H1, 2, 3, 4, 5, 6. C4H6 would be the molecular formula for butane. Structural formula is going to give you a little bit more information. Think of a structure of a house. That's like the bones of the house, like the concrete, the cylinder blocks for the basement. Maybe it's the 2x4s for the walls. The structural formula is going to give you more information about the structure of the atom, structure of the molecule. There's a couple examples for these structures. You can see it's going to give you the atoms, how many of the atoms. It also gives you more information about the Lewis dot diagram as well. So the structural formula tells you the kind and number of atoms in a compound, the type and number, kind and number of atoms in a compound or molecule. But it also does one thing else, and it does something else. Talks about or shows you the bonding patterns. Also gives you some information on bonding patterns. And gives you some information about the shape, approximate shape of the molecule. Bonding patterns, and it gives you information about the shape of the molecule too. Is it going to be a linear? Is it going to be bent? Is it trigonal planar? Trigonal pyramidal? Is it tetrahedral? So yeah, there's 3 different examples of structural formulas. First formula is 1 carbon. It'd be meth, single bonds, methane. The second one, 2 carbons. 2 is going to indicate eth. Eth what? Ethane, because of single bonds. Third one's going to be 3 carbons is prop. Single bonds are alkanes. This is propane. Structural formula. Condensed structural formula. Very similar to structural formula, but it's written in a different manner. The condensed structural formula It tells you what is attached to each carbon atom. What is attached to each carbon atom? What's bonded to each carbon atom? Carbon. After each carbon atom is listed, after each carbon atom, list the attached elements or atoms that are attached to that carbon. I'll go through an example for this too. Condensed structural formula. We'll figure out that meaning. What does that mean? So again, what we're going through is 4 different types of formulas that we're going to explore with organic chemistry. Molecular. Up? Yeah. Molecular formula tells you total number of atoms and type. Structure shows you the structure of the atom. And condensed structural formula shows you a different form of how things are bonded. In the order. Yep. Let's check out some condensed structural formulas. So I have molecular formulas for the example. I have structural, and then I have condensed structural formula. You could see the difference between the 3 types of formulas. Molecular tells you the atoms and type, and how many. Structure shows you the shape. This tells you what's attached to each carbon atom. So here we go. Let's go through this first one. CH3. So the first carbon, C, has 3 H's attached to it. Second carbon right there has CH3. Second carbon has 3 H's attached to it. Let's check out the last example. From a structural formula, you could come up with a condensed structural formula and vice versa. So here we go. The last example right here, we'll draw this. We'll draw it from the condensed structural formula. Yes, it's in your notes already, but you should be able to come up with this idea. There's a carbon with 3 H's. Okay, a carbon. What's attached to that? An H, an H, an H. CH3. That takes care of the first carbon. Okay, that one's done. Next up, we have CH2. All right, that's connected to a carbon. There's 2 H's attached to that as well. Done. And last off, we have another carbon with 3 H's. So that's attached to a carbon. There's going to be 3 H's attached to that. CH3. That would be propane. Prop indicates 3 carbons. Prop tells you 3 carbons. Ane tells you that there's single bonds in between. Single bond, single bond, single bond. It's an alkane series. At the end of each stick is going to be an electron. Let's analyze it a little bit further in detail. This carbon atom has 4 valence electrons to start off. H has 1 electron to give off. H has 1 electron to give off. H has 1 electron to give off. And it's going to borrow or share 1 with this carbon. Everything within this yellow circle here would represent the dots or valence electrons that bond. There'd be 2, 4, 6, 8 electrons around carbon. If it's a single bond, there's going to be an electron or stick in the north side, the south side, the east side, the west side. That's more for Lewis dot diagrams. But yeah, that's the structural formula and condensed structural formula. Last but not least is going to be the ball and stick model. Ball and stick model here. Let's check it out. The ball and stick model, I'm going to put this on the next page. We saw this earlier in the year when we talked about bonding, talked about ionic and covalent bonding. The ball and stick model tells you the bonding patterns, and the approximate shape the bonding patterns, and the approximate shape of the molecules in 3D form, three-dimensional analysis, 3D picture. So a 3D representation of the molecule. What does it look like? There would have been a couple labs we would have done with the balls and sticks. Take college chem, you might have to buy a kit and you might have to interpret how to make these. Take organic chemistry, you may have to do the same thing as well. Atoms are represented by the spheres or the balls, and the sticks or springs represents the bonds. Are represented by the bonds, or bonds are represented by springs and sticks. Either way, atoms are going to be the colored spheres, the balls. The sticks and springs represent the bonds. Bond types. Is it single bond? Is it a double bond? Is it a triple bond? Yeah, and earlier in the year we talked about types of shapes. We talked about linear was a straight line. We said bent looked like water. We said trigonoplanar, trigonopyramidal, and we talked about tetrahedral. Those are the 4 different types of formulas that we'll explore in this class. We also talked about empirical, which means simplified, which we'll cover a little bit more a little later. Let's watch a flick on types of formulas, and then we'll analyze what this says below. Here we go, types of formulas. Oops.
In this video, you will learn how to use different types of formula to represent organic molecules. The formula used most frequently in our videos has been the displayed formula. This is because displayed formula provides the clearest visual structure of an organic molecule. Here is the molecule butene, showed in displayed formula. It shows all the atoms in the correct order with lines to represent all single and double covalent bonds. Drawing all the bonds for very common molecules can be quite repetitive. For example, here is butanoic acid in its displayed formula. Since this is a common molecule, and as chemists we are clear with the bonding arrangement of carboxylic acid functional group, we also use structural formula to represent organic molecules. Here is the structural formula. As you can see, the covalent bond between the OH is not showing, as we know this arrangement anyway. In fact, we could simplify this further and remove all the displayed bonds like this. Structural formula is often used when writing equations, but the formula doesn't mean that it's always clear what arrangement bonds are in. Here is another example. First, the displayed formula of propane. If we then take out the lines representing the covalent bonds and group our atoms together in order they are arranged, we make the structural formula of propane. Pause the video now and try and draw both the displayed formula and structural formula of pentane, which has 5 carbon atoms. Here is the displayed formula of pentane, and here is its structural formula. Molecular formula is another type used and shows us only the number of each type of atom in the compound. To work out the molecular formula, you simply add up each type of atom. For example, here is the displayed formula of hexane. As you can see, it has 6 carbon atoms and it has 14 hydrogen atoms. The molecular formula of hexane is therefore C6H14. This alone is not very useful, as it does not show us how the atoms are arranged and where the bonds are. If you look at these molecules, they all have 6 carbon atoms and 14 hydrogen atoms. Although you may not be able to name these different molecules, you can see they are very different, but all have the same molecular formula. This is the molecule glucose. Pause the video now and complete the molecular formula for glucose. You should have counted 6 carbon atoms, 12 hydrogen and 6 oxygen atoms, so the molecular formula is C6H12O6. Sometimes the formula is reduced even further to make an empirical formula. The empirical formula is the simplest whole number ratio of atoms in a compound. We need to find the highest common factor, that being the largest whole number that is a factor of 6, 12 and 6 in this example of glucose. They all divide by 6. And so if we do this, we get C1H2O1. We don't show the ones, and so the empirical formula is CH2O. Although empirical formula doesn't show us the molecule or how it is arranged, it does tell us the ratio of atoms in the molecule. Now, at the end of this video, you should understand how to draw organic molecules in displayed, structural, molecular and empirical formula.
All right, let's try this out now. Let's see if we could figure out how to identify this molecule in our notes. All right, below, here it goes. It says, determine the following for the organic molecule. So I have a ball and stick model over here to the right. What is a molecular formula for that compound? Please put in the chat. What is a molecular formula for that compound? Again, the black spheres represent carbon. The white ones represent hydrogen. What's the name of that compound? Once you come up with a molecular formula, please put it in the chat. Thank you. All right, so we just solved for it as well. So hopefully you know molecular formula is going to tell you how many atoms are present. And we know that there's C5. So the black spheres, how many carbons are represented? There's 5. So C5, 1, 2, 3, 4, 5. Control comma brings it on down, C5. And then the white ones represent hydrogen. And I would say how many hydrogen were present in this molecule? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Some of you guys did tell me the answer. The molecular formula for that compound is C5H12. Good. Structural formula, I'll skip right now. Let me draw it really quick, but we'll find it. We're going to upload an image from the internet. How many carbons are there? There's 5. 1, 2, 3, 4, 5. If you have a hard copy, you could do this as well. The first carbon, carbon number 1, has 3 H's off it. 1 to the north, 1 to the west, 1 to the south. This is an H. Attached to every stick here is going to be an H. Second carbon number 2 has 2 more sticks attached. H. H. Same thing for carbon number 3. structural formula. One to north, one to south. H, H. Carbon number 4 has 2 H's. H. And the last carbon has 3 H's there. Carbon number 5. 1, 2, 3. C5, H12. If you're at home, you don't have to draw this in there. You don't put that in there. We're going to actually import an image. It could be represented like this. 5 H's. Instead of putting the H's, you can just put the sticks. As chemists in organic chemistry, with nothing at the ends, it's representing automatically that there is an H there too. Either one of these would work out. But from that, what is a condensed structural formula? Let's analyze this. Condensed structural formula analyzes each carbon as it goes through. So the first one's going to be C. So below, it's going to be C, H. How many H's? CH3. Then you're going to analyze the second carbon. Let's check out the second carbon. We'll see C. It's listed first. C, H. How many? 2. The next one's going to be CH2. Next one's CH2. And the last one's going to be CH3. That is a condensed structural formula for the compound above. What's the name of this compound? Can anybody name this yet? After a few examples of us analyzing. What's the name of this compound? Good. Someone in class did. They said there's 5 carbons. 1, 2, 3, 4, 5. So they knew there was 5 carbons. That 5 was indicated by the prefix pent on the reference table. 5 indicates pent. And they said it's single bonds in between. So therefore it's going to be pentane. I think that's what you said. Pentane. All single bonds in between. Hopefully you could start to understand how we derive the name of that compound. Pentane. Pent tells you 5 carbons. Ane tells you there's single bonds in between the carbons. Pentane. Next up, I'm going to take the structural formula. I'm going to go to a new file, the internet, and I'm going to research structural formula for pentane. So add a new file. I'm going to search pentane structural formula. Click on it. Go to the images on Google, and there will be several structural formulas for pentane. That one works. The first one right there, I like it. Pentane, 5 carbons, single bonds. I'm going to copy that image. I'm going to paste it on it. Pentane. That is a structural formula for that compound. You should understand how we did that. You should be able to do this whole portion as well. 4 different types of formulas. There you go. And we named it. Moving on. Now we're talking about hydrocarbons. This should be a really easy topic right here. Hydrocarbons. If I asked you today which 2 elements are in hydrocarbons, I think you guys would realize that there's hydro, which is H, and carbon's going to refer to carbon. 2 elements in there, hydrogen and carbon. So organic compounds that contain only two atoms. Hydrocarbons are organic compounds that contain only 2 atoms. I'm going to change it. That contain carbon atoms and hydrogen. Only carbon atoms and hydrogen. You guys could tweak your notes if you need to. A hydrocarbon has H and C only. Hydrogen and carbon only. A hydrocarbon is going to have hydrogen and carbon alone, nothing else. Hydrocarbons have specific properties, has specific physical properties. They have low melting points. And low boiling points. When I think of organic compounds, I think of oils. Maybe it's car oil. Maybe it's going to be oil that you use for cooking, vegetable oil. Maybe you think of plastics. I think of gasolines. They're going to have low boiling points. Organic compounds, hydrogens are going to be poor conductors of heat and electricity. That should be an easy one. What do we need for electricity? We need a metal. If there's no metal in there, it's not going to conduct electricity or conduct heat very well. They're nonpolars, dissolve in nonpolar solvents, and they react slower, more slowly than ionic compounds. More slowly than ionic compounds. Reaction rates are different between ionic compounds and organic or covalent compounds. They're held together by van der Waals forces. That's attraction between two molecules. And they're named according to IUPAC system. What does that mean? You saw that earlier in the year. That is International Union of Pure Applied Chemists. Awesome group of chemists that names organic molecules. So how we're figuring out how to name these organic molecules took a lot of time by the society, this union of chemists. Last thing for notes today is going to analyze the prefixes. It's on the reference table. Naming organic compounds or naming hydrocarbons. The name of the hydrocarbon begins with a prefix. Based on the number of carbon atoms. And that's in the reference table. Naming organic molecules is by analyzing the prefixes on table P of the reference table. We already saw this. We'll fill out this chart, watch it flick, analyze examples, and give you time for the exit pass. Plenty of time to do all that. So again, this is in the reference table, table P. You can fill out the prefixes here. You should be aware of what each number represents. Filling it out, double click on the image. Meth is 1. Methyl, methane. Meth is 1. Eth is 2, ETH. Prop is 3. Again, in the reference table if you need it. 4 we talked about earlier is buttes. 5 is pent. 6 is hex. 7 is hept. Pentagon has 5 sides. Hexagon has 6 sides. Heptagon, 7. Octagon, stop sign, 8 sides. Non is 9. And dec is 10. Organic prefixes, they're in the reference table. It tells you how many carbon atoms you have in a compound. Again, continuous chain of carbon atoms. That's going to be the last thing on notes once you have that all set. It's a pretty cool unit once we're all done with it. Putting all this stuff together, it's a nice accomplishment you're gonna feel. Organic prefixes, there they are. Meth, eth, prop, butes, pent, hex, hept, oct. Oct is OC. Shouldn't have made O there. OCT, non, and dec. Let's watch a flick. Organic compounds.
In today's video, we're going to take a look at hydrocarbons, and specifically alkanes. First though, it's worth understanding that this whole area of chemistry is known as organic chemistry, which just means that it's all about compounds that contain carbon. You'll see over and over again in chemistry that carbon is a really useful element for making large compounds, because each atom of carbon can form 4 strong bonds, with the most common atoms to be bonded to being either other carbon atoms or hydrogen atoms. Now, lots of molecules only contain these 2 elements, and collectively we refer to all of these molecules as hydrocarbons, which we can define as any compound that's formed from carbon and hydrogen only. So this molecule, which is called butane, is a hydrocarbon, but this similar molecule, called butanol, isn't a hydrocarbon, because it also has an oxygen atom. The most simple type of hydrocarbons are a group called alkanes, and you need to know the first 4 in the series. The smallest is methane, which contains just a single carbon atom bonded to 4 hydrogens, because remember, carbons always have 4 bonds. Then we have ethane with 2 carbons and 6 hydrogens, propane, which is C3H8, and butane, which is C4H10. Now, if you look at all of these compounds, you'll see that they grow by 1 carbon and 2 hydrogens each time, but otherwise they're pretty much the same. We call groups of organic compounds like this homologous series, and it means that they all have similar properties, and so react in a similar way. It also means that we can write a general formula, which describes the entire series, and in the case of alkanes, the general formula is CnH2n plus 2. This might look a bit complicated, but all it means is that if the compound contains n carbon atoms, then it will contain 2 times n plus 2 more atoms of hydrogen. So if we had an alkane with 3 carbon atoms, like propane, then n would be 3. So it would have to have 2 times 3 plus 2 hydrogen atoms, so 8 hydrogens, which would give it the formula C3H8. Now, you only need to remember these first 4, but you could be asked to use this general formula to work out the molecular formula of much larger ones. For example, octane is an alkane with 8 carbon atoms. What is its molecular formula? Well, we know that for octane, n will be 8, because that's how many carbons it has. So it must have 2 times 8 plus 2 hydrogens. which gives us 16 plus 2, or 18. So its molecular formula would be C8H18. Before we finish, we just need to mention that one of the key features of alkanes is that they're saturated compounds, which means that every carbon atom has 4 single covalent bonds. There aren't any double bonds. For example, if we were to take this molecule of propane and change one of these single bonds to a double bond, then each of the carbons involved would have to lose a hydrogen, and what would have left would no longer be an alkane. Instead, we would class it as an alkene, which we'll see when we take a look at cracking hydrocarbons in a later video. In our next video though, we'll stick with alkanes by taking a look at their properties and seeing how to write equations for their combustion. Anyway, that's all for now. So if you enjoyed it, then...
All right, so there's information about hydrocarbons and a little bit intro to alkanes. Please open up the examples on Unit 10, Topic 1, Organic Basics and Hydrocarbons. Examples, Topic 1, Organic Basics and Hydrocarbons. I think there's 4 questions here. Once we get through the 4, I'll give you time to work on the Exapass, which is very similar to this as well. So 4 questions, the quicker we get through it, the quicker you work on the Exapass. Again, examples, Unit 10, Topic 1, Organic Basics, Hydrocarbons. Question number 1, it says, what is the maximum number of covalent bonds that an atom of carbon can form? What's the maximum number of covalent bonds that an atom of carbon can form? Please put the answer in the chat. Number 1, best answer, please. Roll them on in. Let's go. Thank you. First thing in the notes, we have carbon has 4 valence electrons. Thanks, Joseph. How many more bonds could it have? All right, one could form here. Another one could form there. That's 2. Another one could form there, and another one could form there. So it can form 4 more bonds. 4 H's can attract to that carbon. Best answer is choice D. 1 is D, 4 more bonds. 1 is D. Next up, number 2. A compound that is classified as organic must contain the element what? Please put in the chat. Organic compound must have what element? Leo, what do you think? Carbon. Thank you. Carbon atom must be present for an organic compound. Number 3. Which formula represents a hydrocarbon? Which one of these condensed structural formulas below represents a hydrocarbon? Please put the answer in the chat for number 3. 23 people on live. I'll wait for at least 5 responses. Thank you. Please record your answer in the chat once you have the right answer or an answer. Thank you. 2 for 2. Thanks, Jumila. Two more. 2 more at home. Let's go. We're so close. Best answer, Wendy? B. B is the best answer. Hydrocarbon, H and C alone. Hydrogen and carbon by itself. It's not going to be choice A. Why? Because choice A has an oxygen. That's not a hydrocarbon. Choice C has 2 oxygens smushed in between. And so does choice D. Choice B has H's and C's alone. 3, the best answer is going to be choice B. Thank you. Last question. Hydrocarbons are compounds that contain what, Tristan? B. Question number 4, best answer is going to be B. Those are examples for topic number 1. You can submit it. You don't have to. I'm not grading it. You have 11 minutes to complete the exit pass on this topic. The questions are very similar to this right here. So again, from now to the end of class, please open up the exit pass, Unit 10, Topic 1, Organic Basics. A couple of you guys already did it. Cool. And you have 7 questions on organic basics and hydrocarbons. I'm going to put you in breakout rooms. If you get done early, feel free to leave. That's it for today's class. Be safe. Take care. We'll see you guys next time. If you have any questions in the breakout room, please feel free to ask for help. All right, guys, have a great day. Please complete the exit pass. If you do not finish it for some odd reason, it's due on Saturday. Have a great day. Make good decisions. Join the breakout room. Complete the exit pass for topic number 1. If you have any questions, feel free to ask for help. Please join the breakout room. See you later.